Hello guys, we are back with another Leetcode challenge. Let's see the today's challenge, and the challenge is network delay time. This question is fall into the category of medium and it's a highly liked. So it's a must do question. So let's deep dive into the question. So you have a given a network of n nodes labeled from 1 to n, and you are also given times, a list of travel times as directed is times I, which have possess three values: ui, vi, wi, where ui is the source node, vi is the target node, and wi is the time it takes for a signal to travel from the source to the targets. So what's your duty? uh, we will send a signal from a given nodes, let's say node k, and return the time it takes for all n nodes to receive this signal. And if it possible, then you just return the time it takes. Otherwise, if it impossible to send all receive the signal to the all node, so in that case you are going to return -1. So that solution is pretty much straightforward, but let's understand more this solution with with taking the examples. So I'll just take the first examples. Here is a graphic visualization to present. So you have given these times, and every tuples actually take tell about tells about source node, and what the connection between the source node and target nodes, and what actually time it takes. So first value is denoting the source node, second value is denoting the target node, and third one is denoting the time taken to go to this one from this two. So that's pretty much given in this time input. You have given n is equal to 4, how many nodes is present, and k is equal to 2, the our source node where we just send the signal first. So we are providing a signal from this k is equal to 2, and what's our duty? We have to just make sure every node just got these signals and how much time it takes. So in that case, this takes 1 second, this 3 takes 1 second, and this 4 takes 2 seconds. First it goes to the this 3, then goes to this 4. So the total time taken by these two to reach this 4 is 2. So what we have to return? We have to return the minimum time required to reach the all the nodes. So in that case, the minimum time is 2. In this 2 second, every node got these signals. That's pretty much straightforward. Let's take another example for better understanding. We are going to take I'm going to take the third example. So let me just visualize this thing. So you have given a source node 1, and these and target node is 2, and the value possessed is 1 actually, and the 1 is the time taken. Okay, we have a two nodes, this one and this two, and our source node is actually 2 is right now. So I'm just providing the signal to this node, and I'll just try and see uh, every node got the signals or not. But in that case, there is no any uh, direction to go to the 1, because we can go 1 to 2 but not go to 2 to 1 because it's a unidirectional path. So in that case, this one never got signals. So in that case, I'm returning 1 -1 because this one is not getting any signal. So that's the pretty much straightforward. Here we are just make sure two things. First thing, we have to find out the shortest path for everyone, shortest time taken. If we are able to find out shortest time taken to reaches all the nodes, so we got the answer. And we have to make sure every node gets signals. If any node somehow not get any signal, in that case we are directly return -1. So that's two things we have to note down. But this question is totally resemble to the disaster algorithm. It's a pretty much straightforward and standard algorithm for the graph theory. for finding the shortest path. So this question totally belong to that question. So let me just write the code, then you understand how it's resemble to the digester algorithm. So, and we everyone knows it's a standard algorithm. So first and foremost, I'm just making, and how can we implement the digester algorithm? We just take the priority queue and calling the BFS, which have the smallest distance. We just pop that element and do some computation, and that's the things. So for implementing, but before the implementing the digester algorithm, first and foremost, I have to convert this 2D vector in the form of the graph, because adjacency matrix, this is not an adjacency matrix. So we have first and foremost create a adjacency matrix for that. So let me just create a adjacency matrix pair int of int. I just make a pair int of int because that's one of the reason. I have a weighted graph, I have this one too, so I have to store this value somewhere. So I'll just make out a pair to store this thing. So let's name it graph, and the size of graph is n plus 1. There's n plus 1. Okay, and what's our first duty? Store, travels the times and store into this graph. And for storing this, the first, I'm just try to make this in this two index, I'm going to store this one and this one. So how can I get it? By writing it is equal to 0. I'm just getting this value and store this thing in the form of the pair. So push back in form of pair. So it 1 and it 2. That's it. It's going to store every nodes in the form of the hmm, in the form of the agency, in the form of agency matrices. So after doing that, what's my duty? I'll completed my graph part. Now I'm going to implement my digester algorithm. So you know very well how digester algorithm implement. So first and foremost, let me just create a vector where I'm going to store shortest paths, and initially let's name it distance, because distance or time is both are same in that case. Let's see. So let's say n plus 1 node is there, and every nodes in initially it's int max, because we want to store a shortest distance or shortest time taken. So I'll just initially initialize int max, and after doing this, what I'm going to do, uh, I'll just make a priority queue, priority queue. It's a min heap. So let's complete a main heap function for pair int of int uh, vector pair. Okay, let's copy it because I don't want to waste your times. So control C, control here, I'll just make it pair after greater, make a pair. So PQ, after making the priority queue, what's my duty? I have to push this value in my priority queue. So first value, actually I just push its time taken. If I send the signal from to this two, so what the what was the time taken by to get this to get the signal? It's a 0. So, and I'll just pass this source node, key node, where I just provide the signal, and after and we know the distance, it's also 0 in that. This key distance is also 0 in that case because it's our initial case. So let's deep dive into the digester code. Digester algo. So while I'm just run this code until my pq dot size. If my pq dot size is greater than 0, I'll just uh, do something. If my priority queue size is 0, I'll just break this while loop. So first thing what I'm going to do, I'll just pop the top element from the priority queue. So I'll just pop the top element. After popping the top element, taking the top element and pop this top element. After popping the top element, I'll do the computation to this two. I'll just try to grab all the uh, adjacency list is available on this current. So how can I know about that? Let's write it for uh, again write it to auto because it's easy to write auto eat. And what I'm going to do here, uh, I'll make it a graph. Where I make it graph, I'll just call my current dot second. Why I'm going to my current dot second? Because in that case my first in my first possess the distance or time, sorry, distance, and another taken my source. So I just write it source here. After writing the source, what's my duty? I have to check it if this uh, this what this it dot, it's taking the graph, so it's a first. If dot it first is greater than my distance of what, distance of this current dot second plus it dot second. Actually it dot second in my it dot second if it's possible. So what I'm going to do, I'll just, for not writing again this code, I'll just copy this and paste it here and just push this current dot second plus it dot second into my this it first. And after doing that, what I'm going to do, I'll just push this element pq dot push into the my priority queue. So it dot first and second is contain what is actually contain uh, with the values and e dot first. Yeah, that's it. And every this my distance array is actually filled. After doing this my this distance array is filled with some values. And after that, what I'm going to do, I have to check it out. Let's make a variable ans. Ans initially initialized with the int max for int int I is equal to 1, I greater than, sorry, n plus 1, I plus plus. What we have to check it out. Yeah, if my this I is equal to my int max, if equal to int max, I simply return -1 because if any nodes is not getting any signal, in that case I just return -1, and otherwise it's not the case, I'll just try to find out the max value. So intans or this I, which value is greater is going to show into this ans. And yeah, that's it. After that I'm going to return answer, and let's see that this code is work or not. Okay, I'll just edit n plus 1 capital, it's small, my bad. Okay, run this code again. Okay, somehow I get wrong answer. Int max I just return -1. Okay, my bad, it's int me. I have to initialize with the smallest value, and this accepted. Let's submit this code, and it's accepted. So if you have any doubt in this code, let me know in the comment section. I'll resolve your doubt as soon as possible. Until then, keep grinding.